pair of equations every time you do this. And in the very beginning, until we start doing an application, the first parts are not going to look that great just because I want you to see what the parametric is doing. But the second part that we throw in there with the application, you'll see more of, say I'm a ball player and I'm standing at home plate and I need to hit a ball and I need to clear the fence. And I need to do this, like how long is it going to take my ball to get over the fence? How high is my ball going to be at that time when I'm, say, 300 feet away from me, or however far the fence is? You know, if I'm 300 feet away and there's a 10-foot fence, am I going to clear it when I hit the ball? And we're going to add wind speed in here. You obviously work with velocities. So when we get to that part, they make more sense. In the beginning, we're going to see what we put in here makes us a rectangular equation, which is like your conics, which is why we go through conics with you as well. So we're going to get parabolas, we're going to get ellipses, mostly ellipses and parabolas, a couple of circles, we do circles. So you're going to see two sets when you do this. When you hit your calculator and you put your mode in parametrics, when you hit this and you hit your y equal, you're going to see two sets of equations, an x1, a y1, x2, y2. So they're going to be pairs. And you can see the t out here. So for instance, if I said 45x, there's my t. This is my time parameter. So this is what we're looking at right now. And we'll get to this in a second. The second page shows you how to graph it, but I'm going to walk through this with you. Generally, we set your window somewhere. This is how we're going to set your window. And the only thing we really have to worry about is what we call a t-step. And we'll see that in a second. So if you could kindly put these into your calculator. Put this pair in your calculator and let's see what happens to it. As soon as you hit that one, it comes T. Everything else works exactly the same. Want me to shut that door? Now, before you do anything else, let's go to your window. We're going to set this. We're going to set your time. This is your t. In this case, just a parameter. From -2 to +3. And this t-step, we're just going to start at 0.5. The x and the x max, y max, x scale, y scale, you can leave like that for a minute. Now, watch how fast this goes. You want to pay attention to where it starts because we look for the movement. So when I graphed this, it started here and it looped around. Have you ever been able to make a graph that's not a function on your calculator, right? We've never been able to do this in our y equals, right? Because for one x value, you have two y values. So this is not a function. So this allows us to also make this happen. It started right here, and its orientation, which we call the direction, the path, went this way. It came around, then turned and came this way. So we want to see where did it start and where does it go to. And we keep track of orientation. And for orientation, all you need to do is put a little arrow, like where it starts and where it goes. Now, eventually we're going to do more things with this, but today is just an introduction into watching this thing go, how we're going to change this. What happens with your t-step, what happens with your t-step is this. If I took my t-step and I made it 5, watch what happens. The graph doesn't even look the same, does it? Can't even recognize this. So I go back, maybe I change it to a 1. That one's not so bad. If I go too small, did people get up on time? Again, parametrics. Set your mode to PAR. You're going to get 2 sets of equations. This T-step plays a big role in this. What it does is it kind of monitors how sharp it's going to look. If I make it too small, maybe that gets a little clearer. You got to play with your T-steps sometimes. You want to get it as smooth as possible. When we start doing one, like this really doesn't have a shape per se. When we start doing like an ellipse, you'll definitely notice it because it'll be weird looking until you finally get it smooth enough to look like an ellipse. So all we're going to do is go to your table. We're going to start from -2 to 3, and this is your time, your parameter. This piece is not being graphed. This is still your XY. Oops, this is still your XY. So these are your coordinates that you're graphing. Time is kind of not visible to you just yet. Until we put an application in here, you really don't see the time as much. But these are the coordinates that we're going to graph. So as we graph these, and we're only going to go from here to here, you're going to see where it is you started. See, it came back to the 0? We never had this happen. We're not able to, in your y equals, graph something that's not a function, unless we put it in like y1, y2. But in 1y equals, we can't graph something that has 2 different y values. Parametrics, yes. So if you write this table down, in the beginning I just kind of want you to keep writing the table down and keep track of all your pieces. If you want to write it across horizontally this way, this is fine too. Whichever way you want to write it is fine with me. Just make sure you follow the window right now. We'll be setting your window. You'll be setting it in a little bit, but right now I want you just to follow the window. So these are your coordinates. Your XY is still your coordinate points. Okay, so when you graph this, you're sketching. You're starting here. This is where I want you to start. Make sure you remember where you start. You go across, plot your points, wherever your points come out, and just make a smooth line, and just put your arrow here so that we know your orientation. This arrow shows us orientation. Where did it start? What direction does it go in? And when we start doing things where we're shooting rockets off and hitting baseballs and golf balls, you'll see the orientation makes a difference. Even when we start your ellipses, it gives us a starting point and a stopping point. All right, the second page, again, this is just a nice little introduction into how to do this. The second page, again, will just kind of help you go through. Try this. Set your window from -4 to +4. So set your window. You're setting your time. And leave it at like maybe 0.5, 0.2. When these are small, when your times are small, your T-step is going to be small. When we're using an angle when it's 360, obviously our T-step is going to have to be bigger, or this thing will move like really, really slowly. So you can leave it at 0.1, 0.2, 0.5. You can leave your mins and maxes. You're going to decide if you need to change those when you look at your table. So if we don't change our mins and max, let's not change your x right now. So we won't change your x or your y, and we'll see what happens here. So we're going to put your t squared in, and then we're going to put in t cubed. Now when you graph this, it looks a little bit strange, so you're going to have to change your t-step a little bit. I just want you to play with this. Does 1 work better? Is 1 a little bit better? Is it better to be smaller? Just play with it. That's the one thing that's kind of hard to explain, how to set a t-step. Feel kind of safe. And actually, if you look at your table, this is what's happening here. Your table from -4 to +4, look what's happening to your x and your y values. See them? So find your largest and your smallest values for x and y, and then go back and adjust your window. Because you really, well, like when we do this, you really can't tell. When we do an ellipse, you'll obviously see it. These just don't have a figure right now. But I want to set mine, so say this is the highest I see in x right now, 16. This is the lowest I see in y. When I go to +4, I notice I'm at 16 and 64. So I'm going to go to my window, come down here, set my x min to -16, set my x min to -16, set my x max to 16, and then set these guys to -64. You really can't tell just yet, because we don't have a real pattern here yet. And so when you graph it, now you see it a little bit different. So now play with your t-step. Just kind of like work your t-step a little bit. What happens if I say 0.3? Do I get a little closer? Sometimes it gets a little strange looking. If I go a little too high, say I go to 5, what happens at the 5? I only get half of 1. This window for your t is small, so you want to keep this guy small. So, kind of looking like this. Do I notice if it crosses at the 0, 0? Yeah, but it can't get that close to the 0, 0. So when I'm sketching this, my sketch is going to look like this. The only thing I want to pay attention to is where did I start? Where did this start graphing? To make it change, you have to change one thing. Otherwise, it still looks like the same graph. So if you kind of watch, it started here. Here's my orientation. From here, it's going like this. There's my orientation. So when you graph this, you're going to start here, and you're just going to give me one of these, and just go like this. There's your orientation. Get used to writing the table for a little while, so that you can see the t, the x, and the y. The t does not graph on this. The xy pair is what you're graphing. And again, is this a function? No, this is not a function. But that's okay. We're graphing a parametric. By Monday, we'll be graphing it so that they look like ellipses, they look like a circle. And you'll be able to see the whole ellipse graph without putting it in y1 and y2, and without separating it. We can do it over time. It's pretty cool. When we get to the applications, they actually make more sense.
I don't know what you said.
Yeah, is your mode parametric? All done?
No.
Your mode, you gotta put your mode in parametrics. That's because you were on your sneeze alarm when we were putting our mode in parametrics.